Okay, well, the presentation now we advertised as Gems of the Southern Sky using the Worldwide Telescope. You'll recall I introduced the Society to the Worldwide Telescope perhaps a year ago. We had a bit of an explore. And I saw a little while ago some of the observing opportunities in the Australian Sky and Telescope magazine. If we go back about 3 months or 4 months ago, an observing challenge took my eye, and that was, sorry, get the glasses back on, that was called Sparkling Southern Clusters, in the back of, I think, of September. People have their thing, I want to go back, July, Sparkling Southern Clusters. I'll talk about it more in a moment. I've been chasing these. They cover the whole 12 months. You can't see them all on the same night, really. And I thought, oh, this would lend itself, and people might be interested in observing these using the Worldwide Telescope. There are a fair few clouds lately. It's been difficult to get out of. Has anyone actually taken up the challenge in that article to look at those? No? Well, let's do that tonight. And the way I'll run it is, well, as you may or may not remember, the Worldwide Telescope. I've got I haven't downloaded on this machine, but I found the online version, which is totally free, has a slightly better range of facilities, so I'll use the online version tonight. And the Worldwide Telescope.org, you'll recall, has an Explore section where you can explore work that's being done in a whole range of the NASA programs, and you can delve down into those programs and the imagery that they create. There are a whole raft of guided tours in here through nebular clusters and so on, or you can do your own search, a bit like Alan's doing this alone. Do your own search and observe the individual objects you're searching for. I'll do that. We'll use that facility today. So we'll search individually for these items, and when we find it in the field of view, the reason there's these thumbnails down here is the Worldwide Telescope will show us, or thumbnails of other items that are in this field of view that one might want to go and explore. We won't get sidetracked by them tonight, but just to very quickly reorient ourselves, there are a range of guided tours. We'll use the search function, and these thumbnails, which I have not found any way of hiding, these thumbnails give us hints or thumbnails of other things that are in that field of view. Okay, so I hope you don't mind, but I will read some of this because it's easier to read. And certainly when I'll get to the items in here, I'll read the specific findings of each of these items. Let me just read the introduction to this. Which are the best open and globular star clusters in the southern skies? Whilst astronomers in the northern hemisphere have a Messier catalogue, we don't have a Messier catalogue down here because, of course, the northern hemisphere observers couldn't see the south back in the days of developing the Messier catalogue. So an enterprising person thought, well, so how could I categorise, or what would be the 10 most picturesque ones to look at in the southern sky? There were 2 astronomers that did most of the discovery of these. So there were 2 in the 18th and 19th century when these were first found. The first up is a Frenchman, Nicolas Lasalle, who lived between 1713 and 1762. 1751 and 1752, he was observing from Cape Town with a half-inch refractor. Half-inch refractor. Okay. He found most of the bright open clusters of the southern sky. Well-educated and well-financed, he produced a catalogue of 42 clusters and nebula, as well as a catalogue of 9,776 stars with a half-inch refractor. Which is the best scope? The scope you use the most. That was his best scope. That was his best scope. In contrast, Scotsman James Dunlop, you've probably all heard of Dunlop, he's certainly got a category 2, 1793 to 1848, was not well educated and could not afford a good telescope. Nevertheless, during 1826 he found most of the bright globular clusters in the southern sky. Observing from Hunter Street, Parramatta, New South Wales, with a homemade 9-inch speculum reflector, equivalent to a modern 150 millimetre reflector. Peter, the equipment size of yours, 150. So this was a 9-inch. The reflectivity of the specular mirror was so poor that 9-inch was really only as good as today's 5-inch. Dunlop produced a catalogue of 629 clusters of nebulae. Only 211 of these were subsequently spotted by John Herschel, who observed from the Cape between 1834 and 1838 using an 18-inch speculum. Half of Dunlop's 629 objects turned out to be faint double stars that he was unable to resolve with his poor quality homemade instrument. Never mind, he still found 300 odd. From LaSalle and Dunlop's list, we have selected 10 open clusters and 10 globular clusters that stand out for their sparkling beauty. The list includes objects which beginners will readily locate, as well as others of fainter magnitudes that are more difficult for intermediate to more advanced astronomers. So these are all within reach of a 5-inch reflector. All within reach of a 5-inch reflector. So anything of that size or bigger is going to find these. So they're all within our reach. Just before I go on, I just realised that the other introduction I was going to make. So this July issue is globular clusters and open clusters. The next issue, the August one, are nebulae, the 20 best nebulae. If you're interested and you think these sessions are worthwhile, we could explore those. They're quite picturesque and colourful. And then in the October one, the 20 best southern galaxies, which I've been slowly chasing down, and so there's a good bit. So there's some hidden gems in there, I think. So what we've now got is a list of these objects. Let's go and have a look at them. And let's just see the historical comments from the two early astronomers. First one is NGC 2477. NGC 2477. Does anyone know it? There are so many of those. It's so let's just get started. NGC. What did you say? 2477. And it'll give us a thumbnail across here of the object. If it's a 3-digit one, you'll find 4-digit ones that you do. So sometimes it's a bit hard to find. So let's pan to that item. And I think what we probably need to do, could we turn those? This is working online, so just give it a moment to find it. We can very quickly zoom in and out. Now, recall last time I spent a little bit of time talking about this worldwide telescope. This is actual imagery that you're seeing here. So these are the images taken from the all-sky surveys, digital surveys. So we're not seeing simulations here, we're seeing the actual stars as taken in the digital all-sky surveys. For some of the objects, we can then zoom in on Hubble images and so on. So and you'll see some of those. So this is our first open cluster. Discovered by LaSalle, this is a very rich magnitude 5.8 open cluster of faint stars with a line of brighter stars to the northeast. You may or may not. Of course, it always looks a little bit different. It always looks a little bit different to your naked eye. This saturates the star images. That's this line here, and certainly that's very visible in a telescope. Dunlop described it as a pretty large faint nebula, easily resolvable into small stars, or rather a cluster of very small stars with a small faint nebula near the north preceding side, which is rather difficult to resolve into exceedingly small stars. That's 4,000 light years away. If you want to keep track of where we are, can you read this down here? This is telling us the quadrant of the sky we're in, and this is telling us the constellation that we're in. So well and truly, maybe not legible, is it? So it's probably so small. That's Puppis. It's too small. Maybe I'll have to call those out for you.
I can see it in the back with my glasses on.
Can you put? Well, got nice sharp vision. So that's a pretty open cluster. It looks nice in a telescope.
Okay. Which constellation is it in?
Puppis.
Okay.
NGC 2516. We're going to hop around the sky a little bit. We're hopping in roughly right ascension order. So to actually observe these, if you want to do it in the evenings, you really need to set sort of a target for spring, a target for summer, autumn and winter, because they basically come into the best viewing positions. But the beauty of this program is we're going to ignore that. So this was 2516. Let's zoom out. If you're quick, you might just see where we're going. Did you recognise that? Did you edit Carina before? Is that good? That'd be fast. Let's just go back a little bit broader field. This was discovered by LaSalle. Its bright, scattered stars are only 1,300 light years away and cover an area of 25 arc minutes. Magnitude 3.8, it is easily seen with the naked eye. At the foot of the Falls Cross. Dunlop described it as a very fine cluster, about 35 arc minutes in diameter. Many of the stars are the 6th and 7th magnitude. Figure through 20 by 80 binoculars, it looks somewhat like a camel with its legs towards the Falls Cross.
Some homemade wine.
See, it does if you turn your head about that angle, you can just about see it.
You can certainly, let's just go back. Do we know where we are now?
That's it, sure.
No, that's it. Again, if you can read that, it's telling us, yeah, it tells us we're in Carina as a constellation. So that's certainly a pretty one through a scope, very pretty through binoculars. 3114. We made a mistake, didn't we? This one's very hard to see in an image. This magnitude 4.2 snail-shaped open cluster is 3,000 light years away. With a diameter of 35 arc minutes, its scattered stars are superimposed on a bright part of the Milky Way. Dunlop saw a beautiful cluster of stars arranged in as curvilinear lines intersecting each other about 40 arc minutes diameter. So it's this group of stars here, but I guess in the photograph it's hard to actually see it. You can see where we are. We're on the edge. In fact, that's probably a better view. Yeah. That's a better view of it. In a telescope, somehow all the brighter stars shine out, and you lose all this background noise.
Probably seen it lots and lots of time and never knew its number.
Yes. 3, 2, 9,
Oh,
3.
I have a nice cluster next to the eagle.
Now we're powering. Anyone that's looked anywhere in the vicinity of Eta Carina will know this one. And this one, this colour, because it's a photograph, also all-sky survey is coloured by all the gas and everything. But if you look through a telescope, that's what do we see, Phil?
Blue and grey.
Blue and bright blue-white stars,
Yeah.
twinkling stars, a jet black background.
Yeah.
Um,
You don't,
Yeah, I've seen that one.
you don't really see the nebulosity, you see a bit of a glow, but that's about
Yeah,
it.
that's
Yeah,
right.
that's right.
So only 3293, only 5 arc minutes across, and very distant at 7,600 light years. The colourful stars in the gem cluster shine with a total magnitude of 4.7. Dunlop saw a very small cluster of very bright stars around this cluster, rich in extremely small stars resembling faint nebulae. The next one is
I call them confusing.
that's probably cost me a few dollars, and I was at 3293. 3532. Anyone recognising any numbers yet? I'll put a few familiar ones up in a moment.
That's not updated.
So many people. Does anyone know how to, in these machines, how to actually turn off updates?
You have to go into the setup
I've tried.
control panel.
In this Windows 10, I've tried to find it.
It's control panel, then Windows update, and then you disable it.
That's what I've tried.
There you go. I've looked at that. I see Windows 10. So
Okay. UGC 3532.
see if we've managed to pause the update.
I hope so.
I went mine down for 15 minutes once. I was doing a presentation for 50 people. No one could sing and dance either annuities. I asked a couple of times.
So we're in 3532, found this, LaSalle found this, with Dunlop described as a very large cluster of stars about 9th magnitude with a red star of 7th or 8th magnitude, north following northwest. This one's a pretty one in a very wide field telescope or binoculars. So this one becomes a very strong sprinkling of bright blue-white stars.
My 42 mm eyepiece is perfect for these. 42 mm eyepiece is perfect. Vixen.
NGC 766. Trying to guess its name. Centaurus, wouldn't it?
Yeah, that one.
Stefan's recognising it. It looks at me. So LaSalle discovered this magnitude 5.3 open cluster. Dunlop wrote a pretty large cluster of stars of mixed magnitudes. The greater number of the stars are of a pale white colour. There's a red star near the preceding edge. The cluster is 5,700 light years away. There's a couple of other nebulas close by. So going out a little bit further just gives you a sense of a pretty open cluster.
It's the one I'm thinking of. It shows up quite tightly in when you're sweeping around that one. The other ones are a lot more.
4755. John Herschel compared this open cluster to a superb piece of fancy jewellery. At magnitude 4.2 and 6,500 light years away, LaSalle discovered it with his half-inch refractor. So LaSalle found this with his half-inch refractor.
Oh yeah.
Southern Cross.
Yeah, up next to the North.
Certainly this looks much more spectacular in the telescope.
Yeah.
But I'm sure we all know that one, with the traffic lights across there. But it certainly is pretty. So the dual box.
Beautiful. Maybe an island.
It's got that V shape, you can see that quite distinctly through the telescope. And if you a line across the horizontally across the three across the top, then downwards. Oblique, so what is it? 7 billion.
Beautiful.
Could you just zoom out for the location of that one again, please?
Yes.
So where-
Yes. Please. I'm running too quickly. So it's right at that cross point there,
Okay.
and now we can see the 2 pointers to the Southern Cross.
And the cross.
The
yeah.
cross.
It's next to a mouse or a B cracks.
There, and so it's sitting just there.
Yes, thank you.
And then over here, of course, we've got the Eta Carina.
Would you by any chance showing an infrared view there?
Sorry? No, it's digitised sky survey colour.
Oh, the rain chicken maybe was quite, that stands out. That's an amazing show. It's actually quite fun.
Special filters bring out the actual wavelength of them.
We're in Norman now. Dunlop discovered this open cluster, describing as a pretty large cluster of small stars of mixed magnitude, about 12 arc minutes in diameter. The stars are considerably aggregated towards the centre. You can see it there. That's 4,650 light years away. Okay. They're a group of open clusters. Now let's have a look at a group of globular clusters. And of course, we will know some of these as I type them up, won't we? Let's explore some NGC 104. NGC 104.
Takano.
Know that one pretty well, Phil.
Okay, so we can all see visually the difference between, say, those open clusters that we're looking at and this globular cluster. What's the core difference between the two? An open cluster is
Fairly loose usually.
loose open cluster stars, all of pretty much the same age, all formed out of the same gas cloud. So a large gas cloud that is condensed into stars. Those stars are all in that location, and they will all be roughly the same age in an open cluster. Globular cluster. Here, the group of stars are much more condensed, are gravitationally bound together. They are gravitationally bound. Some of these we believe there are big black holes in the middle of. Some of these we believe that are around our Milky Way are the stripped off remnants of small galaxies that came too close to the Milky Way. But there are a number of theories about the formation of globular clusters. That's still science that's, I don't think, is totally resolved. So these are gravitationally bound clusters.
Squillion of them.
Sorry?
There's a squillion.
There are a lot of them. Yes, I quite enjoy chasing them. There are a lot of them. Surprising. They're under our nose too. A lot of them are under our nose. Sorry, some look at
I was saying that the new stars contain thousands upon hundreds of thousands of stars
yes.
in that globular.
750,000 stars.
Omega Centauri, I think in the centre of that globular cluster, stars are less than half a light year apart.
Yes, so,
Imagine the density of that.
yeah, so if you lived there,
Yeah, it'd be amazing.
yeah, it'd be like moonlight.
Yeah, read the newspaper.
And in observing them, the difference is with an open cluster, you generally want a low magnification so you can
Yes.
see the contrast against the black sky.
Yes, that's right. Yep, good point.
Yeah, see outside of
The
it.
globular clusters, you start off with a low power
Mm.
and you go through higher and higher powers, and the extra contrast will sometimes make the brighter stars in the globular pop out or sort of just twinkle on and off at the edge of your visibility, what you can see on the background of the globe.
Yes, yes,
And,
that's right.
That's the fun bit about them, trying to spot the individual stars, and it just, the Tolkien's description of the Arkenstone in The Hobbit is a good description of a globular cluster,
Mm-hmm.
in my
Yes.
opinion.
I think Stefan's captured it well, and that's certainly what I said through it too.
Mm.
This is one of my favourites. It's not my favourite, but it's one of my favourite globular clusters.
It's very bright on this one.
This is very bright, yes. So, 47 Tucana was discovered by LaSalle. Dunlop described a beautiful large round nebula about 8 arc minutes in diameter, very gradually condensed at the centre. This beautiful globe of light is easily resolved into stars of a dusky colour. He was using that 8-inch speculum mirror. The compression to the centre is very great and the stars are considerably scattered southwest and northeast. This distance is 14,700 light years, and of course the small Magellanic Cloud is nearby. You can see as we duck right in here, it's only the things in the field of view is only the 47 Tucana. But if I zoom out, just giving it a moment, it's going to start telling me of other things that are in this field of view, most of which are then in the small Magellanic Cloud. But we won't get there tonight. For now.
There's a couple of globules in the small Magellanic Cloud, you can see the 6-8 inch.
There's some things having apoplexy for some reason. Okay.
There's a video driver update.
Looks like it, doesn't it? 1261. Another globular cluster. Not far away. Exactly the same principle, just a little bit different. Horologium. Horologium? Constellation? This one seems brighter than its listed magnitude of 8.3. It's about 7 arc minutes across and 53,000 light years away. Dunlop found it and described it as a very bright round nebula, pretty well defined and gradually bright to the centre. Globular clusters are rare in this part of the sky.
Is that the one in Palo?
No, we'll come to that one. Gee, I hope we make it through the night. No, this is in Horologium. Horologium.
About 5 o'clock.
Yes. Right, essentially. I can't read it. 1261. So we're 55 degrees south, 3 hours. All right. I was saying before that there are globular clusters under our noses everywhere. Observed in the sky, and when you're looking for them, quite often they are just this little indistinct spot that isn't quite star-like. And then, if you're in a wide field, as Stefan said, zoom in a bit, and you'll see that. Remember, all of these are within reach of our scopes. So NGC 1851. 1851. These are all going to look remarkably similar, but that's Columba we're in now. Very bright condensed in this one. This gem is 39,000 light years away, magnitude 7.1 and 12 arc minutes in diameter. Dunlop described this superb globular cluster thus: an exceedingly bright, round, well-defined nebula, about 1.5 arc minutes in diameter, exceedingly condensed almost to the very margin. This is the brightest small nebula that I have seen. I tried several magnifying powers on this beautiful globe. A considerable portion around the margin is resolvable, but the compression to the centre is so great that I cannot reasonably expect to separate the stars. So this one, as you can see, is very bright.
What's the distance of that one, did you say, sorry?
39,000 light years away. If you're using the worldwide telescope and just searching this, and you want information about that item, if you right-click on the item, you get a bullseye and a bit more information. Globular cluster in Colombo, in its name, right ascension, alternate altitude. But down the useful information here, if I can, how do I get it come up? If I can just get that to come up, is this whole tool allows you to show the object is really just, will show any Hubble or other imagery of it. But you can, this, if you click there, that'll take you to the NASA research libraries, and it'll automatically search, a bit like a Google search, and find all the information that we know about that globular cluster. So if you want to explore that, get information about it, understand it, you click there and go to the, essentially go through the NASA research archives. It's quite an extraordinary tool. NGC 2808. Before we go there, I'll just put that. Nice where we went. Back into Carina. Back into Carina. Just go back out again, because we're getting their bearings. This one's in a much stronger star field.
You could, pardon me, I was just going to say you could spend all night just around that one area of the sky.
Easily.
Well, you'd probably spend a week.
A week, easily. You can do your whole observing through this tool. Dunlop found this magnificent globular cluster and wrote of it: a very bright, round nebula, about 3 or 4 arc minutes in diameter, very gradually bright to the centre. This has a fine globular appearance. Magnitude 6.2, 31,000 light years. 3, 2, 1. I haven't ventured too far. We're in the far south. So we're just looking in the far southern. So we're now in Vela. This is a pretty one. It's away from that red influence of the hydrogen influence of the other things. This globular cluster has a low concentration of stars. You're right. Is only 16,000 light years away, magnitude 6.9 and 20 arc minutes across. Dunlop found it, describing it as a pretty large, pretty bright, round nebula, very gradually condensed towards the centre, easily resolved into stars. The figure is rather irregular and the stars are considerably scattered on the south preceding side. The stars are also of slightly mixed magnitudes. Yes, through a telescope this is a pretty one because you, whereas with Tuck and Omega Centauri, the centre part really is burnt, is strongly glowing, and it's hard to actually get resolution of stars. This one resolves quite nicely. 5139. That's it? That's it? So this is our naked eye favourite, but a lot of people say it's their favourite one. Oof. Oof. Man. It's bright. Also known as Mega Centauri. Edmund Halley found this superb globular cluster from St Helena Island in the South Atlantic in 1677. Magnitude 4, 55 arc minutes in diameter, so it's virtually a degree in diameter. You don't, virtually a degree in diameter. Twice the size of the
Twice the
moon.
moon, yeah.
Twice the size of the moon. You don't sort of get, you lose track of that when you're looking at it. Twice the size of the moon. 17,000 light years away. Dunlop described it as a beautiful, large, bright, round nebula, about 10 or 12 arc minutes in diameter. So he obviously, even with an 80 specular mirror, there's a lot he couldn't see. You could only see that bright central condensed flame. It is a beautiful globe of stars, very gradually and moderately compressed to the centre. This is the largest bright nebula in the southern hemisphere, and the best in the world.
Probably the most numerous too, wouldn't be surprised.
The most
Numerous.
It may well be, yes, and
The very largest.
it's the very largest, and this is certainly one where we believe there's a large black hole.
That's black hole in the centre, yeah. There's 1.1 million stars estimated in
Okay.
What, sorry?
1.1 million stars estimated in there.
6397. As large as that one. Just over the other side of Mara. This one was found by LaSalle, with Dunlop describing as a pretty large nebula extended nearly in the parallel of the equator, brightest and broadest in the middle. The nebula is resolvable into stars. This low concentration globular cluster is only 7,500 light years away, 30 arc minutes in diameter, so the size of the moon, magnitude 5.3. This is one of my favourite ones, just visually. One of my favourite. 3 more to go. 6541. Corona Australis. This has got just got a last number 2. This one was found by LaSalle with Dunlop described. Oh no, sorry, 541. Niccolo Cariatore discovered this one on March 9th, 1829 from Palermo, Sicily, so he must have seen this right on the horizon. While searching for a comet, Dunlop independently discovered it in 1826. He saw a very bright, round, highly condensed nebula, about 3 arc minutes in diameter. He could resolve a considerable portion around the margin, but the compression was so great near the centre that it would require a very high power, as well as light, to separate the stars, he wrote. The stars are rather dusky, he wrote. It is 24,000 light years away, and its magnitude 6.3. Six, 723. Sagittarius, room. This was discovered by Dunlop in 1826, 28,000 light years away, magnitude 6.8. Dunlop saw a beautiful, bright, round nebula about 3.5 arc minutes in diameter, moderately and gradually condensed at the centre. It is resolvable. The bluish colour of the stars which comprise it give it a very soft and pleasant appearance. This is rather difficult to resolve, although the condensation is not very great. Bluish, bright and dark nebula are nearby. So again, this photo has been covered by the... Yes, you can see some other things to explore around this one. Rather than do that, we'll just look at our very last one. And then 6, 7, 5, 2, 6, 7, 5, 2. into parvo now. Dunlop also discovered this one, describing it as a pretty large and very bright nebula. Irregular round figure, easily resolved into a cluster of small stars, exceedingly compressed at the centre. The bright part of the centre is occasioned by a group of stars of considerable magnitude when compared with those of the nebula. I'm inclined to think that this may be two clusters in the same line. The bright part is a little south of the centre of the large nebula. This magnificent starfish-shaped magnitude 5.3 globular cluster is 13,000 light years away. In fact, I think this one's probably my favourite. It's easy to find. It's in parvo and always high in the sky. High in the sky. In fact, this one is a good, easy hop to one of the best galaxies in the southern hemisphere. We're in parvo. Does anyone know that hop? If I just go back out, if people, I can put the Constellation on. So we're in parvo, the Peacock, and that star there is Peacock, the star Peacock. And if we zoom back in, that star and these stars, I'll take those constellations off again. From a visual point of view, star hopping that and those three stars are easy to find. You can see there's the globular cluster just there. And come back down to this star and duck down here. We see one of the better southern galaxies. And if I put the thing on it, so this is NGC 6744. Some people might recognise or see before. And that's sort of 5-inch telescopes and above. That's definitely resolvable into a round haze. And in moments of better seeing, you'll just start to get a hint that there are arms to it. If we just go back out, we can duck back up to there, which is the globular cluster that we were just looking for. Okay, I'll finish the article here. It says, so there you have it, 10 each of the best open and globular star clusters in the southern sky. In subsequent articles, we'll provide similar lists of nebula and galaxies. Until then, we encourage you to get out the telescope and hunt them down.
Well, good on Slough and the Sky and Scope for actually coming down to the southern hemisphere, because it's northern hemisphere at altitude, hasn't it?
At the time, yes, at times. Although they do. Yep. Yes, every now and again an article, an observing article sneaks in here that is really low on our horizon, that's for sure.
Yes.
That's for sure. Yeah.
They also had a series last year on binocular objects.
Yes,
which is
yes.
also good. I tried quite a few of them on, some of them on telescope, and one or two you couldn't tell it was a cluster because the field of view was too narrow.
So, I have as a project to the task is the wrong word. You know, I have the project to see all of those visually through my telescope. If you have a look at the notes on, you can turn on next. If you have a look at the notes scribbled on here, you'll see that I've found about half of them so far. I've just got to wait for the right time of the year to see the other half. So I find those sort of tasks quite interesting, but perhaps it's an idea for people to think about what to look and observe through the telescope. What was the worldwide telescope? That's finish that part of the presentation. We'll just.
I'm going to give you a clap.
Time to move to a wrap up of things. just before we do go, future events, most important thing, and Peter has actually, has everyone managed to get a copy of Peter's little